Okay, so in this example, I've got a log equals log equation. There is no expanding or condensing that I actually need to do because I just have one single log on both sides. So my first step is actually going to be to exponentiate to get rid of the log. I know that my base on both of these logs is a 10, so I'm going to start with 10 as my exponentiating base. The 10 and the log are then going to go away, and I'm left with 16 plus b equals b squared minus 4b. Okay, from there, I see that I have both b's and b squareds in my equation, so I'm going to want to set this equal to 0 and try to factor it. So I like keeping the b squared positive, so I'm going to actually subtract b and subtract my 16 on both sides. Okay, that way I now have 0 equals b squared minus 5b minus 16. Okay, off to the side, I'm going to make my factor x. So I'm going to think of two numbers that multiply together to give me negative 16, add together to give me negative 5. So my factors of 16 could be 16 and 1, 8 and 2, 4 and 4, and it looks like none of those are going to be able to add together to give me 5, so that means I have to use quadratic formula. Oops. Let's see. So when I use quadratic formula, I remember that the formula is x equals opposite b plus or minus the square root of b squared minus 4ac all over 2a. When I plug in my values from my equation, I'm going to have x equals opposite b, so in this case positive 5, plus or minus the square root of negative 5 squared, which is 25, minus 4 times a, which is 1, times c, which is negative 16, all over 2 times a, which is 1. Then I just need to clean up under the radical, and I should be getting, let's see, 25, negative 4 times 1 times negative 16 is going to give me positive 64 all over 2. And then when I add my two numbers under the radical, I get positive 5 plus or minus the square root of 89 all over 2. When you have to do quadratic formula, I'm not super concerned about valid or extraneous solutions because those are going to be kind of a pain to plug in.